Hi, welcome to Harris Maths. Here are a few questions based on fractions, percentages and decimals. First we're asked to write 30% as a fraction. So if we have 30% as a fraction, the percentage sign means out of 100. So this is identical to saying 30 over 100. If we divide the top and the bottom by 10, we'll have 3 over 10. And this is the simplest form of the fraction that represents 30%. Next, we're asked to write 2/5 as a decimal. Well, this line here means to divide. So this is actually saying 2 divided by 5 and to write it as a decimal. You might be able to memorize some of these, but this is how you do it if you have to calculate it and show you're working. So we have 5 out here and we're dividing 2 by 5. The numerator is divided by the denominator. So we ask ourselves, how many 5s are there in 2? There are none. We put a decimal point here and a decimal point because now we're moving from the singles column now to the tenths. We have a remainder of 2. So now we ask ourselves, how many 5s are there in 20? There are 4. And we know when we subtract 20 from that, we end up with 0. So our answer is 2/5 written as a decimal is equivalent to 0.4. Next we're asked to write 7/10 as a percentage. Well, if you have a fraction, in order to convert it to a percentage, we need to multiply by 100. So that's 7 over 10 multiplied by 100%. If we divide across in this direction by 10, we have 10 into 10 is 1, and 10 into 100 is 10. That gives us 70%. Here's a question. In a school, 2/5 of the children wear glasses. What fraction of the children do not wear glasses? Well, if 2/5 wear glasses, it's always part of a whole. So the remainder to a whole will be the ones who do not wear glasses. And we know a whole is 5/5. So if 2/5 wear glasses, 2/5 taken away from 5/5 will leave us with 3/5. And 3/5 of the people do not wear glasses. Next, what percentage of the children do not wear glasses? In our previous problem, we had a fraction. If we have a fraction and we want to convert this to a percentage, we need to multiply by 100%. We divide in this direction by 5. 5 into 5 is 1. 5 into 100 is 20. 23 is 60%. So 3/5 do not wear glasses, and that's equivalent to 60% of the class. Number 17, there are 30 sweets in a bag. 20 sweets are red. What fraction of the sweets are red? Well, 20 out of the total of 30 sweets in the bag are red. So this is the fraction, but it's not in a simplified form, in the simplest form. So we need to simplify this to make it, we divide both top and bottom by 10. Maybe we cross off that. And we're left with 2/3. So 2/3 of the sweets are red. Number 19, in a town in Cornwall, it rained for 13 days during April. What fraction of the days in the month did it rain? Well, in April, there are 30 days. And if 13 of those days it rained, then the fraction of days that it rained would be 13 out of 30. We cannot simplify this fraction because there are no common factors other than 1 of 13 and 30. So the fraction of days in the month that it rained is 13 over 30. Number 20. During the day, Madeline slept for 6 hours. What percentage of the day is Madeline awake? So if she slept for 6 hours, and we know that there are 24 hours in the day, then we know that she was awake for 24 take away 6, which is 18 hours. And what percentage of the day is Madeline awake? Well, she's awake for 18 hours. And that's 18 out of the total day, which is 24 hours. But again, we need to simplify this. We'll divide by the common factor of 6. 6 into 24, 6 fours, 6 into 18, 6 threes. So she's awake for 3/4 of the day. And now we need to convert this fraction to a percentage. As before, to convert a fraction to a percentage, we multiply by 100%. We'll divide in this direction. 4 into 4 is 1, and 4 into 100 is 25. 25 threes are 75. So Madeline is awake for 75% of the day. Number 21. Danny scored 9 out of 10 in a quiz. Just by looking at this, we know that he did very well. What percentage of the questions did Danny answer correctly? Well, 9 out of 10. That's how it's written. 9 out of a total of 10 questions. To convert this fraction to a percentage, we multiply by 100%. We divide in this direction by 10. 10 into 10 is 1. 10 into 100 is 10. 10 nines, 90%. So Danny answered 90% of the questions correctly. Write 17% as a fraction. Percentage means out of 100, so this is the same as saying 17 out of 100. So 17 out of 100. We cannot simplify this fraction anymore because 17 is a prime number and only has one common factor of 1 between itself and 100. So we can't simplify this. Next, write 7 over 20 as a percentage. To convert a fraction to a percentage, we multiply by 100% times 100%. We divide in this direction by 20. 20 into 20 is 1. 20 into 100 is 5. 7 fives are 35. So if you had a test and you got 7 out of 20, you would have had 35%. Write 14 over 25 as a percentage. Again, we multiply this by 100%. Divide in this direction by 25 to give us 1 here and 4 here. 14 fours are 56. Write 1 over 8 as a decimal. Well, this, as I mentioned early on, means 1 divided by 8. So 1 divided by 8. How many 8s are there in 1? And none. We had a decimal point here and 1 here, and we had 0. How many 8s are there in 10? There is 1. And we have a remainder of 2. So we add another 0 here, and we have the 2 as the remainder there. How many 8s are there in 16? There are 2. 8 2s are 16, and we have a remainder of 4. We add another 0, and we put the 4 just above here. How many 8s are there in 40? 8 5s are 40. We have no remainders. So 1/8 as a decimal is equivalent to 0.125. And that's it on decimals, fractions and percentages. Hi, welcome to Harris Maths. Suppose you're given this algebraic fraction divided by another algebraic fraction, and you're asked to write a single algebraic fraction and simplify if possible. So first we'll write the first algebraic fraction, x squared over b. Now we're dividing by b cubed over 4xy squared. Means it's the same as multiplying by the inverse of this algebraic fraction, which is 4xy squared over b cubed. The inverse is simply 1 over, in this case would be b cubed over 4xy squared, which is equivalent to 4xy squared over b cubed. And now we can simplify. So we have 9 times 4, which is 36. We have a on its own. We have x squared, and we have an x here, so that gives us x cubed. And we have y squared on its own. And b times b cubed is b to the 4th power. We do not have anything else to simplify, so this is our final answer. And here's an algebraic fraction. We're multiplying a to u squared times 2 over u squared add u. We want to write this as a single algebraic fraction, and to simplify it, what we'll multiply this numerator, because we can write this as 8u squared over 1, numerator by numerator will give us 16u squared in the numerator, and this times 1 is u squared and u. But before we move on and say we're finished, we cannot cancel anything as it is, but we can simplify our denominator by factorizing it. We have u is common to u add 1. And now we can simplify this further by cancelling our u here with this u to leave a u in the numerator. So we have 16u divided by u add 1. Let me just write that. We have 16u squared, and if we factorize our denominator, we have u into u add 1, and then we can cancel here, can give us 16u u over u add 1. Let's write that so you can see it. 16u divided by u add 1. And that's it. My name is Alistair. If you have any questions or comments, please feel free to send them to me. Don't forget to like, subscribe or follow for more videos like this. Thanks and bye for now. Hi, welcome to Harris Maths. Here's another example of a partial fraction. And so first we write the equivalent in terms of constants. That's a over x minus 2 add b over x squared add 4. Now if we look at this denominator, we have this term x squared. And so instead of having just a single term b as our constant, it actually implies that we should have bx add c as our constant, or two constants in fact. Secondly, in order for us to proceed, we need to multiply each side by this denominator here. And so we have the left hand side will cancel to x add 3, and that's equivalent to a brackets x squared add 4 add bx add c. We have x minus 2. And now we need to go ahead and substitute values for x to eliminate constants and find what's remaining. Now if we want to eliminate both b and c here, we can set x to positive 2, and then this will reduce to 0, and the left hand side now is 2 add 3, that's equal to a into 2 squared add 4. So we have 5 is equal to 8a, given that a is equal to 5 over 8. Next, we are going to eliminate b, so we'll set x equal to 0. So first we had x equal to 2, and we eliminated all of this, b and c. Now we'll set x to 0, which will eliminate b, and then we'll be able to find c because we do know a. So this now becomes 3 is equal to a 4 times that. This is 0, and we'll have c times 0 minus 2, which is negative c, minus negative 2c, sorry. So we have 2c now is equal to 4a minus 3. So c is equal to 4 times 5 over 8 minus 24 over 8, and multiply all of this by 1 over 2, which is the same as dividing by 2. So this is equal to 20 over 8 minus 24 over 8. So we have this c is equal to a half times 20 over 8, take away 24 over 8, so it's a half times minus 4 over 8, which gives us minus a quarter. So our second constant, c, is equal to minus a quarter. So finally, we'll substitute any value, preferably a small value for x, so that we can find what c is. B. We actually found c. So we know c is minus a quarter, a is 5 over 8. So we'll set x equal to, let's say, 1. So this becomes 4. We have a into 1 squared add 4, which is 5. Add bx, well, that will just be b. Add c, we know c is a quarter, and we're multiplying this by 1 is x, so it's 1 minus 2, which is minus 1. If we simplify this, we have x now is equal to 5a minus b add a quarter. We can substitute for a and b, and then, sorry, for a, we now need to find for b. Well, let's just rearrange. We have b is equal to 5a add a quarter minus 4. So we write that 5a now is 5 times 5 over 8, add quarter minus 4. We'll have a common denominator of 8, so we'll make this 25 over 8, add 2 over 8, minus 32 over 8. Which works out to be minus 5 over 8. So if we rewrite our original fraction, x add 3 over x minus 2, x squared add 4. Now we can use our constants that we just calculated. So a was 5 over 8, so this becomes 5 over 8 brackets x minus 2. Add b, but we know b is negative 5 over 8, so this becomes minus 5 x over 8 into x squared add 4. And c we know is minus a quarter, so it becomes minus 1 over 4. Just to write this a bit neatly, we can write this as 5x over 8 minus a quarter all over x squared add 4, which simplifies to we cross multiply here, we have 20x minus 8, and we use this in the denominator here. 8 fours are 32. That's into x squared add 4. And this is a simplified form of writing x add 3 over x minus 2 times x squared add 4 as partial fractions. Thanks for watching. Please like, comment and subscribe for more videos like this. Bye for now. Today I'll talk about a useful tool in maths called partial fractions. As with most of maths, the concept of simplifying things before you work on it or being able to do things in a reverse order is paramount. Suppose we had a function f of x and we define it as x add 1 over x squared add 1. We can express this function f of x with a common denominator and write this x squared 1 which simplifies to but it's also quite useful to be able to reverse the process. So if given a function in this form, being able to express it in this form. So if we can go from this way, from this result to what was initially given. And this is the concept of partial fractions. Here's another example. This is our function on the left, and we can express this in partial fractions. We use constants a and b. These constants are determined based on the power of our unknown x here. As a single power, so our constants will be just simple constants a and b. Now our numerator is equivalent, and this explains that this is an identity, meaning whatever's on the left can be replaced by what's on the right and vice versa. Now all we've done is equate this numerator to the combined numerator here on the right. Now to solve this, we just substitute values for x to eliminate one of the constants. So we'll start with x equal to 4. That will give 4 take away 2. That's equal to this is 0. So we have b into 4 and 3. So we have 7b is equal to 2. So b is equal to 2 over 7. Next, let's rewrite this. We'll set x to -3 to eliminate a. So x equal to -3 will give us -3 minus 2 will be -5. And this is equal to a to -3, -4. So we have -5 is equal to -7a. So a is equal to 5 over 7. So now we've calculated our two constants. A, which is equal to 5 over 7, and b equal to 2 over 7. So now we rewrite our function using constants a and b. So a is 5 over 7 into x, add 3, add 2 over 7 into x minus 4. This is what's called decomposing a fraction into partial fractions. We started with this on the left hand side and we found the constants a and b, and now we rewrite the original with using the constants a, which is 5 over 7, and b, 2 over 7. You can check this by expanding and resolving to see that you end up with what's on the left hand side. My name is Alistair. If you like these videos, please like, comment and subscribe. Bye for now.